2005 National Electrical Code, or NEC, pocket guides are generally well regarded by electrical professionals because they are portable and easy to use. They are compact and easily carried in a pocket or toolbox, which makes them convenient for quick reference at job sites. The 2005 NEC pocket guides provide information on code changes, highlighting the key changes and additions made in the 2005 NEC compared to previous editions. They also contain Articles 90.110, which covers fundamental NEC requirements, including definitions, general installation rules, and system grounding. Further, they have Articles 111.210, including information on branch circuits, feeders, and overcurrent protection devices. Articles 215.230 provides details on lighting and motor circuits. Articles 230.250 covers grounding and bonding requirements. Articles 300.398 includes rules for wiring methods and materials such as conduit, conductors, and cables. Articles 400.480 provides information on motors, generators, transformers, and other electrical equipment. Articles 500.525 covers requirements for hazardous locations. Articles 530.590 includes information on special occupancies, such as healthcare facilities and assembly halls. Finally, the pocket guides provide essential NEC tables and charts for easy reference. While the pocket guides are valuable tools, it is important to note their limitations. Firstly, they do not replace the full NEC code book. The pocket guides provide a summary of key provisions but do not include all the details found in a full code book. Secondly, they may be outdated. Since they were published in 2005, they may not reflect the latest revisions and amendments to the NEC. Thirdly, they are not suitable for design or engineering purposes. The pocket guides are not comprehensive enough to use for designing or engineering electrical systems. In conclusion, the 2005 NEC pocket guides are useful references for electricians and other electrical professionals who need quick access to code provisions at the job site. However, it's crucial to use them in conjunction with the full NEC code book and keep up with the latest code revisions for accurate and up-to-date information. Let's delve deeper into specific areas covered by these pocket guides. For instance, regarding branch circuits, feeders, and overcurrent protection, which are found in Articles 111.210, the NEC defines the branch circuits as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Feeders, on the other hand, are all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit overcurrent device. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from excessive current that could cause overheating or damage. The pocket guide summarizes the key requirements for sizing conductors and overcurrent protection devices based on the ampacity of the conductors and the rating of the equipment they supply. Moving on to grounding and bonding requirements, which are discussed in Articles 230.250, grounding refers to connecting electrical equipment and systems to the earth. This provides a low impedance path for fault current to return to the source, which helps to trip overcurrent protection devices and prevent electrical shock hazards. Bonding, on the other hand, involves connecting different metallic parts of an electrical system together to create an electrically conductive path. This helps to minimize voltage differences between these parts and reduce the risk of electric shock. The pocket guide summarizes the key requirements for grounding electrodes, grounding conductors, bonding jumpers, and other grounding and bonding components. When it comes to wiring methods and materials, covered in Articles 300.398, the NEC specifies various approved wiring methods for different applications. These methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and various types of cables. The pocket guide summarizes the key requirements for each wiring method, including the types of conductors that can be used, the support requirements, and the installation requirements. In hazardous locations, addressed in Articles 500.525, The NEC has special requirements for electrical equipment and wiring to minimize the risk of ignition. Hazardous locations are classified based on the type of hazardous material present, such as flammable gases, vapors, or dust, and the likelihood of the material being present in ignitable concentrations. The Pocket Guide summarizes the different classes and divisions of hazardous locations and the types of equipment that are approved for use in each location. Finally, regarding special occupancies, which are discussed in Articles 530.590, the NEC has special requirements for electrical installations in certain types of occupancies, such as healthcare facilities, assembly halls, theaters, and recreational vehicle parks. These requirements are designed to address the unique electrical hazards that are present in these occupancies. The Pocket Guide summarizes the key requirements for each type of special occupancy. To provide a more comprehensive understanding, let's consider some examples of how the 2005 NEC Pocket Guides can be used in practical scenarios. Imagine an electrician is working on a commercial building and needs to install a new branch circuit to supply power to a lighting fixture. The electrician can use the Pocket Guide to quickly reference the requirements for branch circuit wiring, including the minimum size of the conductors, the type of overcurrent protection device required, and the grounding requirements. Another scenario is an electrician working in a manufacturing plant that has areas classified as hazardous locations due to the presence of flammable vapors. The electrician can use the Pocket Guide to determine the appropriate types of electrical equipment and wiring methods that are approved for use in these locations, ensuring that the installation complies with the NEC requirements for hazardous locations. An electrical inspector reviewing a new electrical installation in a healthcare facility can use the Pocket Guide to verify that the installation complies with the special requirements for healthcare facilities, such as the requirements for essential electrical systems and patient care areas. Now let's discuss the importance of understanding the limitations of the 2005 NEC Pocket Guides. Because the Pocket Guides provide a summary of key provisions, they may not include all the details found in a full NEC codebook. This means that electricians and other electrical professionals should always consult the full codebook for complete and accurate information. Since the Pocket Guides were published in 2005, they may not reflect the latest revisions and amendments to the NEC. The NEC is updated every 3 years, so it is important to use the latest edition of the code to ensure that electrical installations comply with the most current safety standard. The Pocket Guides are not comprehensive enough to use for designing or engineering electrical systems. Electrical design and engineering require a thorough understanding of electrical principles and the NEC, as well as the use of engineering calculations and software. The Pocket Guides are intended to be used as a quick reference tool, not as a substitute for proper design and engineering practices. To ensure that electrical installations are safe and compliant with the NEC, it is important to use the Pocket Guides in conjunction with the full NEC codebook, keep up with the latest code revisions, and consult with qualified electrical professionals when necessary. Understanding the scope and purpose of the NEC is critical for safe electrical practices. The NEC is not a design manual, nor is it intended to provide detailed instructions for every possible electrical installation. Instead, it establishes minimum safety standards for electrical installations to protect people and property from electrical hazards. The NEC is developed and maintained by the National Fire Protection Association, or NFPA, a non-profit organization that develops codes and standards to reduce the risk of fire and other hazards. The NEC is updated every 3 years through a consensus-based process that involves input from a wide range of stakeholders, including electrical contractors, engineers, inspectors, manufacturers, and other interested parties. The purpose of the NEC is to provide a set of uniform rules for electrical installations that can be adopted and enforced by local jurisdictions. By adopting the NEC, local jurisdictions can ensure that electrical installations within their boundaries meet minimum safety standards. While the NEC is widely adopted and enforced in the United States, it is important to note that it is not a federal law. Each state and local jurisdiction has the authority to adopt and enforce the NEC as it sees fit. This means that there may be variations in the electrical codes that are in effect in different parts of the country. Electricians and other electrical professionals should be aware of the specific electrical codes that are in effect in the jurisdictions where they work. In addition to adopting the NEC, many local jurisdictions also have their own local amendments to the code. These amendments may address specific electrical hazards or issues that are unique to the local area. It is important for electricians and other electrical professionals to be aware of any local amendments to the NEC that are in effect in the jurisdictions where they work. The NEC is organized into chapters, articles, and sections. The chapters provide a broader overview of the different areas covered by the code, while the articles provide more specific requirements for particular types of electrical installations. The sections provide detailed instructions for complying with the requirements of the article. The NEC also includes a number of tables and figures that provide additional information and guidance. These tables and figures can be helpful for calculating conductor sizes, determining overcurrent protection requirements, and selecting appropriate wiring methods. The NEC is constantly evolving to keep pace with changes in technology and industry practices. New editions of the code are published every 3 years, and these editions include revisions and amendments to address new electrical hazards and improve safety. It is important for electricians and other electrical professionals to stay up to date with the latest edition of the NEC and to understand the changes that have been made. One of the key areas covered by the NEC is grounding and bonding. Grounding and bonding are essential for protecting people and property from electrical shock hazards. Grounding involves connecting electrical equipment and systems to the earth, while bonding involves connecting different metallic parts of an electrical system together. Grounding and bonding provide a low impedance path for fault current to return to the source, which helps to trip over current protection devices and prevent electrical shock. The NEC specifies detailed requirements for grounding electrodes, grounding conductors, bonding jumpers, and other grounding and bonding components. Another important area covered by the NEC is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from excessive current that could cause overheating or damage. The NEC specifies the types of overcurrent protection devices that are required for different types of electrical installations, as well as the requirements for sizing and installing these devices. The NEC also addresses wiring methods and materials. The NEC specifies various approved wiring methods for different applications, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, and various types of cables. The NEC also specifies the types of conductors that can be used with each wiring method, as well as the support requirements and the installation requirements. In addition to these general requirements, the NEC also includes specific requirements for certain types of electrical installations, such as those in hazardous locations, healthcare facilities, and other special occupancies. These special requirements are designed to address the unique electrical hazards that are present in these locations. The NEC is a complex and comprehensive document that covers a wide range of electrical topics. Electricians and other electrical professionals should have a thorough understanding of the NEC in order to ensure that electrical installations are safe and compliant with the code. To further clarify, let's consider the importance of understanding the code articles referenced in the 2005 NEC Pocket Guides. For example, Article 90, Introduction, provides the purpose, scope, and arrangement of the NEC. It clarifies that the NEC is intended to provide practical safeguarding of persons and property from hazards arising from the use of electricity. It is essential to understand this article to properly interpret and apply the code requirements. Article 100, Definitions, defines the terms used throughout the NEC. Understanding these definitions is crucial for accurately interpreting the code requirements. For instance, the definition of grounded versus ungrounded conductors is critical for proper wiring and grounding practices. Article 110, Requirements for Electrical Installations, covers general requirements for electrical installations, including workmanship, conductor identification, and equipment listing and labeling. This article sets the foundation for safe and reliable electrical installations. Articles 210, Branch circuits, and 215 feeders provide detailed requirements for branch circuits and feeders, including conductor sizing, overcurrent protection, and voltage drop calculations. These articles are essential for designing and installing electrical circuits that can safely and effectively supply power to electrical equipment and devices. Article 250, Grounding and Bonding, covers the requirements for grounding and bonding electrical systems and equipment. Proper grounding and bonding are critical for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. Articles 300, Wiring Methods, and 310, Conductors for General Wiring, provide detailed requirements for wiring methods and conductor types. These articles are essential for selecting and installing the appropriate wiring methods and conductors for different applications. Articles 430, Motors, Motor Circuits, and Controllers, covers the requirements for motors, motor circuits, and controllers. These articles are essential for designing and installing motor circuits that comply with the NEC requirements for motor protection and control. Articles 500 through 516, Hazardous Locations, cover the requirements for electrical installations in hazardous locations. These articles are essential for ensuring the safety of electrical equipment and personnel in environments where flammable gases, vapors, or dust may be present. To illustrate the practical application of these code articles, let's consider a few examples. An electrician installing a new branch circuit in a residential dwelling would need to refer to Article 210 to determine the minimum size of the conductors, the type of overcurrent protection device required, and the number and type of outlets permitted in the circuit. An electrical engineer designing a new electrical system for a commercial building would need to refer to Article 215 to determine the appropriate size of the feeders to supply power to the branch circuits. An electrical contractor installing electrical equipment in a hazardous location would need to refer to Articles 500 through 516 to ensure that the equipment is approved for use in a specific hazardous location and that it is installed in accordance with the NEC requirements. An electrical inspector inspecting a new electrical installation would need to be familiar with all of the applicable code articles to verify that the installation complies with NEC requirements. In conclusion, the 2005 NEC Pocket Guides are a valuable tool for electricians and other electrical professionals who need quick access to code provisions on the job site. However, it is crucial to use them in conjunction with the full NEC codebook and keep up with the latest code revisions for accurate and up-to-date information. A thorough understanding of the code articles referenced in the Pocket Guides is essential for ensuring the safety and reliability of electrical installations.